So the first scenario where you would normally utilise the undercut would be when we have the free end saddle. So for example, if we have our premolars like so, and then we've got the molars missing, we've got a saddle area like this, we may as well get the saddle to engage that undercut distal to the 5 in this case, and gain some retention here. It's not going to be huge, but it's going to help. And the other occasion is when we have a class 4 situation, because if we use the path of displacement as in being perpendicular to the occlusal plane, we end up with a funny little triangle of light in between the denture and the abutment tooth. So what we tend to do is tip the model backwards on the surveyor such that the path of displacement, we create a path of insertion that runs down the long axis of these abutment teeth, and in that case you get the denture fitting snugly against the side of these abutment teeth, and you don't get that funny little triangle of light. So that's creating a path of insertion. The bits that I said I would come back to were regarding free end saddles and why we moved the occlusal rest for a free end saddle. So if this is our scenario here where we've got the free end saddle, a couple of premolars and not very good canine, and then a couple of incisors and so on duplicated on the other side, so we've got bilateral free end saddles. You could, conventionally, in the past, occlusal rests have been designed on the distal of the abutment tooth, and then of course we have the survey line somewhere here, and typically we'd have some kind of clasp, in this case a gingerly approaching clasp here, and this is considered poor design for several reasons, and I'll try and explain these now. So there's one reason with regards to support, so we changed the design to a mesial rest to improve support. We also do it to provide indirect retention, and thirdly we do it to provide cross arch bracing. We'll discuss each of those now. So let's start off thinking about support then. So we'll draw this again. If we had a free end saddle situation, and we've got a couple of premolars as above, and then the canine coming off something like this, and so on and so on, and we've got our saddle area like this, and we fill it with denture like so, and we happen to design incorrectly an occlusal rest there on the distal of the tooth, and we've got our survey line like so, and we've got our clasp in that undercut area. When you're thinking about support to start with, so the first reason you're thinking about support, and support is this resistance to movement down towards the mucosa, remember. What happens in this scenario? Well, this is a tooth and mucosa borne denture, and what happens is this mucosa here can be compressed, and when occlusal load is applied, that mucosa compresses and we get movement in the denture, and that movement, when we have a distal occlusal rest, pivots around that occlusal rest. So everything behind that pivot moves down, and everything in front of the pivot moves up. Okay. So what we find is that as this pivots, the clasp arm here, the clasp tip, is in front of this pivot and engages the undercut and pulls up on the tooth like so. So we get this wrenching action on the abutment tooth, and it's aggravated by the fact that the load is being transmitted down the distal aspect of the tooth as well. So you're getting load down the distal aspect. The whole thing's rotating around that occlusal rest. The clasp arm, the clasp tip is engaging in that undercut and exaggerating this, or contributing to this rotational force on the tooth. And this is considered destructive and causes abutment teeth to displace. So a better design is to, let's draw this again, move the occlusal rest further forward or distant to the saddle area, or the opposite side of the clasp tip, whichever way you want to word it. Slightly large canine there, never mind. So same scenario, we've got a saddle area here, putting load down onto the saddle area, and we've got our survey line and our clasp tip in there, gingerly approaching clasp. But this time, if we put the occlusal rest on the mesial aspect of the tooth, what happens now is, as the load gets applied to the occlusal surfaces of the teeth, load may get transmitted down through the occlusal rest, but it's running down the mesial aspect of the tooth, and if anything that would try and tip the tooth forwards, and it can't be tipped forwards because it's got a tooth adjacent to it which is going to resist that forward movement. But it gets better than that, because now we've moved the axis of rotation forward, and it's critically the other side of this clasp tip. So this is the axis now about which the denture is going to rotate. Okay, and look at the action of the clasp tip now as it does rotate. As this gets pressed down, the clasp tip is the same side as the saddle, the same side as the saddle from the occlusal rest. So this is going to move down in the same direction around this pivot. So it's going to disengage from the tooth, and thereby it won't cause any damage. So this is considered good. Distal occlusal rest, poor. Okay, and that's to improve the support or protect the teeth when you're loading the free end saddle. So that's number one on our list of why we move the occlusal rest to the mesial side of the tooth. So let's go over the page. We also move the occlusal rest to improve retention. So same scenario, a couple of premolars, free end saddle, big canine like this, saddle in there, or our denture in there, and now we're considering retention. So that's resistance to movement away from the mucosa. Same survey line like so. We'll put our clasp arm in, gingerly approaching, and if we had a distal occlusal rest like so, what would happen when we're pulling the denture up with some sticky food, so when the denture is trying to be displaced? Well, imagine what happens. The occlusal rest doesn't really play a part in the mechanics of this at all. It just simply leaves the surface of the tooth, and what happens is the clasp tip here is in the undercut. It gets lodged in the undercut and acts as a little pivot here, and then the whole denture tries to start to rotate around that pivot. So the clasp actually isn't being very effective, it's just causing the denture to rotate. So what we should do is one of two things: either move the occlusal rest to the mesial part of the tooth, which I'll show you now, or add another occlusal rest further forward. So let's see what happens when we move that occlusal rest, like so. So here's our scenario again. This time we're going to have our saddle area on, but we're going to put our occlusal rest on the medial aspect of the tooth. We have the same survey line, we've got the same load pulling up, and we've got our clasp tip here in the undercut area. Now what happens is when something pulls up on this denture, or when the denture gets displaced, the clasp tip gets stuck in the undercut, tries to become a fulcrum, and it tries to set the RPD rotating like that, but the removable partial denture can't, because this occlusal rest is on top of the tooth on the opposite side of the axis of rotation. So the denture is going to rotate about that axis there, and it can't because this occlusal rest is on top of the tooth. So what actually happens is, as it tries to rotate, this occlusal rest becomes the fulcrum and the denture starts to rotate about that point there, which means the clasp tip has to move up the tooth bodily like this. So it's engaged in the undercut, and rather than rotating on the spot as in this scenario, it has to move up the tooth, and that means that the clasp is being far more effective, and this is called indirect retention. So indirect retention is really a method of changing the axis of rotation such that the clasp tip moves up the tooth bodily and improves the overall retention. And when you start thinking about this, the further we have this occlusal rest from the clasp tip in the saddle area, the better. So if we had an incisal rest upon one of the laterals or the centrals, not very aesthetic I know, but if we did that, that would be the best indirect retention, because we'd then be rotating around this point here, and the clasp tip would have to move up the tooth even in a more parallel direction to the long axis of the tooth. So this is indirect retention. Funny term really. Indirect retention, and for indirect retention we want the occlusal rest on the opposite side of the clasp tip to the saddle area. So this is considered a good design, this one poor. And as I said before, you could have, to provide your indirect tension, you could have a distal rest and an additional one further up here. But that wouldn't be so great with regard to support. So generally we just put mesial rests on when we've got free end saddles. And the final reason for moving the occlusal rest to the medial side of the tooth is to provide cross-arch bracing, and this one's not quite as easy to draw. So imagine we've got a couple of premolars, something like this, and then canine, and then laterals and centrals and so on around here, like so, canine, and another couple of premolars. So this is going to be our saddle area down the back, like so. And then you can imagine if this was a large teeth for a lower, but if this was a lower, it's difficult, and the alveolar ridge is resorbed. That's the most challenging situation to provide bracing, i.e. to stop the saddle areas moving sideways like this at the back. And it is suggested that if we put mesial rests in like so when we have a free end saddle, and these are of course connected up with one of our nice rigid connectors like this, something like this. This is all our rigid connector around here. Now what happens when this saddle attempts to move in this direction is that we rotate around this occlusal rest here, and because all of this connector is rigid and that occlusal rest is sat within a rest seat within the tooth, it's jammed in there, that can't move backwards. So as this saddle area tries to move in this direction, the denture has to rotate around this occlusal rest, which is linked rigidly to this occlusal rest, which stops the whole thing moving. And this is called cross arch bracing. So it's used when we have free end saddles, and it's the third reason why we move the occlusal rest from the distal of the abutment tooth to the mesial of the abutment tooth. Okay, I think that's it for now. I'll do a couple of videos next week of actually designing if you wish. Okay.